Today we're going to talk about 2.5. I just want to mention to you again that you can pause this if you need to go back over something or rewind it and listen to me again. This hopefully should be review for logarithm functions, so you may need to spend a little bit more time reviewing them based on what you have as your background. So the first thing we're going to start off with is what a picture of a logarithm looks like. And so a reminder that a logarithm is actually saying that you're solving for the exponent. So the base, which is a, stays the base. So a to the y equals x. What do I raise my base to give me x? That's how you're always converting. It's solving for an exponent. Understanding that helps when you're doing these problems. Logarithms and exponents are actually inverses of each other. So when you look at a graph, the y equals x line here means that it will mirror image on both sides. This is just to kind of give you some background. You will not be graphing logarithms for this course, but it is helpful to understand what the shapes look like, to know that you're getting the correct pieces. Remember that for exponential graphs, the domain is all real numbers, but the range is 0 to infinity. It doesn't ever reach 0. Since they're inverses of each other, the logarithm will have a domain of 0 to infinity and a range of negative infinity to infinity. So that means, really important, this has to be greater than 0. Again, a refresher for you. Here's your properties. If we have multiplication of what we're taking a logarithm of, we can split it up into addition. If we have division, we can split it into two separate logarithms with subtraction between them. C is the power rule. You can pull down the power in front. That's a really helpful one. D is really a definition because remember, it's saying what do I raise my base to get that value. So a raised to the first power is 1. That's my exponent. E is saying what do I raise a to get 1, and it has to be 0. If the bases match, which they do in F, you can think of it again, it's actually using several of these properties, but because they're inverses of each other, they essentially cancel out, and you're left with the exponent. Last one on here is your change of base formula. You can always change a base, and whatever you change it to, though, it has to have that logarithm, that base on the top, and that logarithm base on the bottom. So here again is the reminder. This is saying, remember this is my domain, okay, and my base is always positive. So the first problems we're going to do real quickly here, we're just going to convert. It's just reminder, this is just basic practice for you. So remember, a logarithm is solving for the base. Remember, the logarithm is solving for the exponent. So this would be, keep my logarithm, same base, it solves for the exponent. Logarithm, keep your base, it solves for the exponent. Converting to exponential form, remember again, you keep your base, and a logarithm is solving for the exponent. If there is no base written, it is always assumed to be base 10, which is a common log. So 10 to the negative third equals 0.001. So that's just a quick conversion going both directions. Going to our next two problems here, we're evaluating each logarithm without a calculator. So we're going to take this logarithm and convert it to an exponential form. So 9 raised to what power is 81? Solving this exponential, as we learned in the last sections, you need to get a common base base is 3. Once they match, you can solve the exponents. Double check that my answer is a possibility of having, which it is in this case. My answer is x equals 2. For number 2, 3 raised to what power is 1 over 81. Again, we're going to get the same base, which is base 3. Since it's in the denominator, it's going to be a negative exponent. Once they match, you drop it and solve.